take a look at the public key encryption with sodium, which is going to be very similar. We've already got it installed, so all I got to do is import this and import private key in box. So let me just go to my environment here. I'll just keep going. So that'll import that stuff. And now I'm going to generate some keys. So I'll put this stuff in, and again, I'm going to have to add some print statements to it right at the end. So this is going to generate a private key using the latest algorithm, and then it's going to encode it in hex, and now I'm going to print it out here. This is the secret key, this is the private key, and this is the public key there. And so public and private key should both print, which this one printed it out. We'll see if it prints out under these conditions. Maybe I'm going to have to add a print statement or something. Let's see. All right. See how I run this one? There we go. I get the public key, but I didn't get the private key, so I guess I need to just add it. Print skbob. Then the AI guessed what I was doing, as it should. Okay, so there's the secret key. There we are. The secret key is this, and the public key is that. And it's, you can think of it as RSA, but it isn't. It's some more modern algorithm that's better. But the point is, you keep the secret key secret, and anybody can send you messages with the public key. So now we'll generate keys for Alice. This is the typical thing you do. Alice and Bob are the two people that communicate whenever you use encryption algorithms. So that'll generate a secret key and a public key for Alice. All right. And now we can encrypt it. So we're going to send this message, hello from Bob. Here it is. And we're going to create the ciphertext by encrypting with Bob's key. That's what you do. Oh, no, from Bob. Excuse me. No, here, no, with Alice's key. There.
Alice is sending the message.
Yes. So here, we take decoded PK Alice. Right, that just gets her public key. And now we create a Bob key, and this is going to use a private key and the other person's public key. So what it's doing is encrypting with my private key and her public key, so I think it's also signing it.
So it's integrity.
Yes,
reason.
I think so. Yeah. That's why it needs my secret key. So that's what this is going to do. It's going to encrypt this stuff so Alice can read it, and she can verify my identity, I think, with the public key. I think that's included.
So if we reverse instead, we would be, if this is integrity driven,
yeah.
The other would be that avoid the tampering with the data. So you
That's integrity. Integrity is avoiding tampering. Yeah.
Okay. So
the other one, the other one is confidentiality. Is the other. Yeah, that's right. It just has both of those. Yeah.
But by simply reverting the order, wow, you tap into the different notion of security.
Well, no. I mean, the way we did it in RSA, we only used the public key of the other person, so we did not add any integrity control. Or any authenticity. This appears to have authenticity as well as integrity.
But per se, without any salt, I'm not using any salt. I have a public key and a private key. If I decide to encrypt with the public and decrypt with the private, I'm ensuring what aspect of security?
Confidentiality. Because anybody, if you encrypt with your private key, then anybody can decrypt with the public key. So you do not have confidentiality, but you have authenticity. Yeah, you have proven who you are. Exactly. Very good. All right. So that should do this. This will create there.
Sorry, I insist on these notions because these notions are a little bit slippery.
Yeah. Well, you know, now I'm not having to add the print command, so this is screwy. But anyway, here we are. This is the ciphertext. This long mesh here. All right, which is in hex now. So instead of having unprintable characters, I'm just printing the hexadecimal values. Another way to express it. All right, and now I can decrypt it again. To decrypt it,
now Bob is decrypting.
This is a message, hello from Bob, so Alice can decrypt it. And Alice decrypts it with her secret key and his public key. Her secret key decrypts it, and his public key verifies his identity. That's the idea. So we'll get the plain text. All right. And there we go, we get the plain text. So that's the game. Like I say, it's really pretty easy, and you don't need to worry about the algorithm or size or anything. It automatically chooses the best one, which is what normal people would want. People should just use this rather than thinking so hard. Anyway, so that's all I wanted to show you about that one.